So what are we going to discuss in our lecture? First, we'll discuss about the basic structure of feedback amplifier and its underlying operation principle. What are the main components of the feedback amplifier? How does it work? And then we'll see some properties of the negative feedback amplifier. What are the merits of this negative feedback amplifier? And what are the different feedback topologies? Topologies here actually means there are different types of feedback depending on the type of the signal that we want to feedback, and from that we get different feedback topologies. So at the end we discuss about the different feedback topologies. So this diagram here shows the basic structure of a negative feedback amplifier. The main components of the feedback amplifier is one is this basic amplifier, and A is the gain of that basic amplifier, and the other important block of this feedback amplifier is the feedback network. So the feedback network, what is the function of this feedback network? Feedback network, it samples the output signal. As you can see, signal sampling at the output. So the one of the function of the feedback network is to sample the output signal, and then it produces a feedback signal which is denoted as XF, and that is supplied at the input side, and it is mixed with the original signal source which is denoted as XS, source signal. So this feedback signal is mixed with the source signal, and as you can see, here we have a summer sign. So the function of this block here is to add these two signals. Add, when you see that this side is plus and this is indicated minus, so that means basically this will add in a way that it will be feedback signal will be subtracted from the signal source, and the resultant will be fed back to the basic amplifier. So this is we call the mixing of signal at the input. So the feedback network will sample the signal from the output, produce a feedback signal, and that feedback signal will be mixed with the source signal, and the resultant will be applied to the input of the basic amplifier, which will then be amplified by the basic amplifier. So this is how the feedback amplifier will work, and this is the basic structure, and this diagram is also known as the signal flow diagram of a negative feedback amplifier, how the signal will flow through a feedback amplifier. And note the term negative here. Negative means that the feedback signal, we have a minus sign, and feedback signal will be subtracted from the source signal. That's what it means, negative. If it is a positive feedback, then it will be added to the source signal. But we also have positive feedback amplifier, but for very different purpose. And here our main focus is on the negative feedback amplifier, how the negative feedback amplifier is used to improve the different performance features of the amplifier. Now the Xi here is the difference between the two signals. One is the source signal, the other is the feedback signal, and that is known as the difference signal. So Xi basically is the difference signal that goes into the input of the basic amplifier, and the output X0, that is the Xi is amplified by the basic amplifier get the output x0. So x0 is AXI, where A is the x0 by Xi, that's the gain of the basic amplifier. And then that x0 is sampled by the feedback network, which produces signal xf. So xf is our feedback signal, and beta is the ratio of xf by x0, and that is our feedback factor. And so these are the main terminologies associated with the feedback amplifier. You see that the one is the gain of the basic amplifier A, the other is the feedback factor and of the feedback network, that's a beta, and the other one we have here is the gain with feedback, the overall gain, that is x0 by xs. X0 is our output signal, or actual input is xs, this source signal, and the ratio is, we call it overall gain or gain with feedback, since this also includes the feedback network. So that is the overall gain or gain with feedback. Now our next task will be to determine what is the gain of this feedback amplifier. So in order to determine the gain of the feedback network, we start with the difference signal xi, that is xs minus xf. Now xf is the output of the feedback network, and that is we can write as beta x0. So replacing xf by beta x0, we get this. And x0 is the output of the basic amplifier, and which is given by AXI. So replacing x0 by AXI, so we get this expression for xi. Now rearranging the terms in this equation, we can express the signal source xs as the summation of xi plus this, and that way you can express like this. Now the gain with feedback, that is x0 by xs. Now x0 is AXI from the output of the basic amplifier, and xs we have just derived this expression for the signal source in terms of xi and replacing that. Now you see that xi and xi will cancel out, and AF, the gain with feedback, it can be expressed by this expression. So that is our gain with feedback in terms of the gain of the basic amplifier and the feedback network. So that is how the overall gain of the feedback amplifier will depend on the two factors. One of the gain of the basic amplifier, the other is the feedback factor of the feedback network. Now one obvious conclusion we can draw from this expression, that this term here is less than 1. This is less than a, because a is being divided by this factor and this is greater than 1, and obviously so this expression will be less than a, the magnitude of the gain of basic amplifier. So obvious conclusion we can draw from this expression, that gain with feedback will be less than the gain of the basic amplifier. So the first effect that the feedback network will have on the overall gain, that reduces the overall gain from the gain of the basic amplifier. So that is the first effect that we can see, that the negative feedback reduces the overall gain of the amplifier. So if it reduces the gain, then what is the use? We still use feedback amplifier. So now we'll see another consequence of the negative feedback. So that was our expression for the gain with feedback AF in terms of the gain of the basic amplifier and feedback factor beta. Now in this expression, and let's say that the product A beta is much larger than 1. So if this is true, product A beta is much larger than 1, then we can express 1 plus A beta approximately equal to A beta. Since A beta is much larger than 1, so we can make this approximation, and then the gain with feedback, so 1 plus A beta replaced by A beta, A will cancel out and you get AF equals 1 over beta. So gain with feedback, the expression for the gain with feedback reduces to this expression 1 over beta. Now this is a very interesting expression. This is very simple and interesting and very significant expression. This is a significant result. And why it is very significant? What is the significance of this very simple expression? Because you see that the AF, the overall gain or gain of the feedback amplifier, depends only on the feedback factor beta. It does not depend on the gain of the basic amplifier A. The overall gain of the feedback amplifier, negative feedback amplifier, is independent of the gain of the basic amplifier. The gain of the feedback amplifier does not depend on the gain of the basic amplifier. It depends only on the feedback factor beta. Now, what is the significance of this expression? Significance is this, that the gain of the basic amplifier is subject to many variations. Gain of the feedback amplifier is a strong function of temperature. If temperature varies, the gain also varies. And there is a wide fluctuation of temperature over the year from summer to winter. And over the geographical location, if you are North Pole or in South Pole, the temperature can vary by as much as 100 degrees Celsius. Or at different altitudes. The aeroplanes, they fly very high in the sky. The ships, they go down into the ocean. So they will have very different temperatures. And the temperatures can vary again by large margin. And if there is so much of difference in temperature over the geographical location, over the period of the year or the altitude, you know that circuit can malfunction. The car companies, they produce the cars not for one geographical location, but for all different geographical locations. Not for just one season, but they produce it so that it can work for all seasons. So that gives, because of that, you need to stabilize the gain, stabilize the performance of the amplifier, as the gain of the basic amplifier is strong function of temperature, and when temperature varies by that big margin, only as big as it can be 100 degrees Celsius, your circuit can malfunction and whole system will collapse. Your car can crash, an aeroplane can crash as well. So this will be devastating, will have a devastating effect. And what is the solution? And the solution is the feedback. And as you can see, if you design a properly negative feedback amplifier, you can make the gain independent of the gain of the basic amplifier. So in this expression we see that the overall gain or gain with feedback depends only on the feedback factor beta. It does not depend on the gain of the basic amplifier. Basic amplifier gain can vary because of the temperature or geographical location or many other different reasons. But if you are using feedback, then your gain has now become independent of the gain of the basic amplifier. It depends only on the feedback network, and the feedback factor beta is quite stable because feedback network are made of the resistors. You are sampling the voltage or current, so mostly it is made of resistors, and the values of resistors that does not change that much with temperature. Very uh, small change you can have, but that will not uh, affect your output significantly. So you can have a quite stable output, quite stable gain by applying the negative feedback to your amplifier. So that is the biggest advantage merit of negative feedback amplifier, that it stabilizes your gain. Your gain becomes independent of the gain of the basic amplifier. It is determined only by the feedback factor beta. Now, that is not the only performance improvement, only benefit that you get with the negative feedback. There are many other performance improvements that we get by applying the negative feedback. So first of all, it stabilizes the gain, and then we can also get an increase in the bandwidth. So it widens the bandwidth. It reduces the noise. The signal noise will be reduced, and it reduces the nonlinear distortion. Sometimes you get distortion in the output that can be reduced if you apply the feedback, and also you can adjust the input and output resistances. So in some cases we'll need higher output resistance or lower output resistance, or sometimes we'll need lower input resistance or higher input depending on our application and types of signals. So different situation we need different level of input output resistances, and that we can achieve by applying the negative feedback. So these are the different performance improvements that can be achieved by applying the negative feedback, and all of these achievements are we get by the reduction of the gain. So that is the price you pay in order to get these performance achievements. So though we get a reduced gain, reduction in the overall gain, but the improvements that we get in the other aspects of the performance of the amplifier always outweigh our the reduction in the gain, the price we pay.